somewhere in the Egyptian desert sits a block of stone weighing as much as 10 elephants. No engine lifted it, no crane carried it, no truck hauled it across the sand, and yet it rests perfectly stacked, over 100 meters above the ground, part of a structure that has already outlived every empire built after it. So here's the question worth sitting with for a moment. How did people with no metal machines, no electricity, and not even the wheel in any usable form for this kind of job, manage to move stones heavier than a modern shipping container, and stack them with a precision that still confuses engineers today? And even stranger, how did they do this not just in Egypt, but on remote islands, in European fields, in South American mountains, all without ever talking to each other? To really understand this, we need to rewind further than most people expect. Long before pyramids or standing stones, early humans lived in small groups where building meant piling a few rocks over a grave, or stacking stones into a low windbreak beside a shelter. The size of anything they built was limited by the size of what a few pairs of arms could carry. If a rock was too heavy to lift, it simply stayed exactly where it had always been. For most of human history, ambition was capped by muscle. But at some point, someone had an idea that quietly changed the future of construction forever. What if you didn't try to lift the stone at all? What if, instead, you dragged it? This was the very first breakthrough, deceptively simple, almost boring on the surface, but genuinely revolutionary. Builders realized that a heavy object slides far more easily than it lifts, so they began cutting blocks directly from stone quarries, wrapping them in ropes twisted from plant fibers, and pulling. Not one or two people, but dozens, sometimes hundreds, working in rhythm, chanting together to stay synchronized, dragging the stone forward inch by inch across open ground. It worked, but it came with a punishing problem: friction. Dragging a multi-ton block across dry sand or rocky terrain felt like dragging it through thick mud. Ropes snapped under the strain. Workers collapsed from heat and exhaustion. Progress crawled forward in meters per day, not kilometers. If ancient civilizations wanted to build anything on a massive scale, dragging alone was never going to be enough. Something had to change. And what came next might be one of the cleverest low-tech solutions in engineering history, so pay attention, because this one is almost too simple to believe. Builders started placing wooden sledges beneath the stones, and then pouring water directly onto the sand just ahead of the sledge's path. That sounds strange until you understand the physics behind it. Wet sand is actually firmer and offers less resistance than dry sand, because water binds the loose grains together into a more solid surface. Ancient Egyptian tomb paintings actually show exactly this: workers pouring liquid in front of a massive sledge being hauled by dozens of men, and for a long time, historians assumed this was purely ceremonial. It wasn't. Later experiments confirmed that wetting the sand in front of a sledge could cut the required pulling force by close to half. So now the stones were moving faster across flat ground. But here's the next wall they hit. Moving a stone horizontally is one puzzle. Lifting that same stone 30, 50, even over 100 meters straight into the sky is an entirely different nightmare, and this is where the real ingenuity begins to show. The most widely supported explanation for massive vertical structures like the Great Pyramid involves something surprisingly low-tech: ramps. Not a single steep incline, but long, gradually sloping paths built from packed rubble, mud brick, and debris, constructed alongside the structure as it grew taller layer by layer. Workers dragged the stone blocks up these gentle slopes using the same sledge and water method, and as each new tier of the structure was completed, the ramp itself was extended and raised to keep pace. It was slow, it was grueling, but it converted an impossible vertical lift into a long, walkable slope, because moving something up a gentle incline requires only a fraction of the force needed to hoist it straight up. Of course, ramps created a brand new problem of their own. The taller the structure grew, the longer and steeper the ramp needed to become, which meant exponentially more material, more labor hours, and more risk of collapse. So builders adapted again. Some evidence points towards spiral ramps that wound around the outside of the structure like a staircase, saving valuable space on the ground while still preserving that same manageable slope all the way to the summit. Other theories suggest internal ramps built directly into the body of the structure itself, hidden from view and only discovered by modern scanning technology centuries later. And ramps and sledges were far from the only tricks in the ancient toolbox. Builders also relied heavily on the lever, one of the simplest machines in existence, yet astonishingly powerful. By wedging a long wooden beam under one edge of a stone and pivoting it over a smaller rock or block acting as a fulcrum, a handful of workers could lift one edge of a multi-ton stone just high enough to slide another support underneath. Repeat that motion patiently enough times, from every side, and you could gradually walk an enormous block upward, layer of support by layer of support, without ever needing a crane. This is exactly where things get genuinely fascinating, because civilizations with zero contact with each other were solving this same core problem in strikingly similar, yet independently invented ways. On Easter Island, the massive stone statues called the Moai, some weighing more than 80 tons, were transported across miles of uneven terrain with no wheels and no ramps at all. For decades, archaeologists were completely stumped, until researchers tested something based on local oral tradition. They attached ropes to either side of an upright statue and rocked it side to side, essentially walking it forward the same way you'd wrestle a heavy refrigerator across a kitchen floor without lifting it. It worked. The statues quite literally walked to their final resting places, one rocking step at a time. Meanwhile, at Stonehenge in England, builders faced a completely different kind of challenge. Some of the massive bluestones used in the monument weren't even sourced locally. They had to be transported over 100 miles from Wales, likely using a combination of wooden sledges, log rollers acting almost like primitive ball bearings, and river transport by raft along waterways. Once those stones finally arrived, lifting the horizontal slabs, called lintels, on top of the vertical standing stones required earthen ramps, simple lever systems, wooden platforms, and teams of workers pulling ropes threaded through timber frameworks, essentially assembling a temporary wooden crane built from nothing but logs and rope. And the list doesn't stop there. In South America, at sites like Pumapunku and Sacsayhuaman, builders shaped stones so massive and cut them so precisely that some blocks fit together without any mortar at all. The joints are so tight that even today, a knife blade cannot slip between them. This level of precision likely came from a slow, patient process of repeatedly test-fitting stones, grinding down high points, and retesting, over and over, sometimes taking years to perfect the fit of a single wall. At Baalbek in modern-day Lebanon, one single stone block in the foundation, nicknamed the Stone of the Pregnant Woman, weighs an almost unbelievable 1,000 tons, and yet it was somehow quarried, moved, and nearly positioned using nothing but timber sledges, ropes, and raw, coordinated manpower. To this day, engineers studying the site still debate exactly how a stone of that scale was maneuvered even a short distance without modern equipment. What all of these sites reveal, once you really study them side by side, is that no single civilization had one magic tool. What they all had was patience, deep cooperation, and a genius for combining simple ideas, ropes, levers, ramps, water, timber, and thousands of coordinated human hands, into systems capable of achieving things no individual tool could ever accomplish alone. And it's worth pausing here to really sit with what that means. None of this was luck. Every ramp angle, every rope thickness, every rhythm of hundreds of workers pulling in perfect unison, was the product of trial and error passed down and refined across generations, until the entire process became something close to an unwritten science. Many historians actually argue that organizing the labor was harder than solving the physics. Feeding, housing, and coordinating thousands of workers for years, sometimes decades, required a level of logistical and administrative planning that rivals any large modern construction project you could name today. Now picture building that exact same structure today. A modern crane can lift a multi-ton block hundreds of feet into the air within minutes, guided by hydraulics and steel cables strong enough to support the weight of an entire house. A single bulldozer could flatten in one afternoon what ancient ramps took months to construct. GPS and laser levels can align a modern building with millimeter precision, something ancient builders achieved using nothing but the position of the stars, the angle of the sun, and an extraordinary trained eye for detail. And here's the twist that should genuinely humble us. Some of these ancient structures remain aligned with astronomical events, sunrises, solstices, specific star positions, more precisely than many buildings constructed with today's modern tools. Somehow, without satellites, computers, or laser measurement, ancient builders mapped the sky and the ground together with such accuracy that thousands of years later, the sun still rises through the exact same gap between the exact same stones, on the exact same day, every single year. So when you ask how ancient humans built giant stone monuments without machines, the honest answer is that they didn't lack machines at all. They simply built entirely different ones. A rope, a lever, a ramp, a sledge, and a few hundred perfectly coordinated hands were their machines. What they lacked in horsepower, they made up for with patience, teamwork, and a hard-earned understanding of physics that came not from any textbook, but from generations of watching stone, water, wood, and rope, and slowly learning exactly how each one behaved under pressure. And maybe that's the real lesson hiding underneath all of this stone. We like to believe progress is purely about better tools, but some of the biggest achievements in human history came from something far simpler than any machine: ordinary people working together, patiently, towards something none of them could ever lift alone.